So the dose response data has been posted to GitHub. It's on the end of the February meetings. I can link to this meeting if I want, and I think I just need to confirm with Dana where she wants it on the wiki, because I suppose it needs to be in both places, but it's all finished and it is posted to GitHub.
Excellent, thank you. Kato.
Yes, so Ed is on vacation, but we've been starting to work on our new fragments, but I think it's better to give a final update when he's back and when we've synthesized them. But you can click on the link and see which fragments we mean. These are based on the 6 dual inhibitors that Beck had a dose response curves on, and there was one that had the better IC50, I guess. So we'll do an update on that next meeting, or when we've had more synthesis done.
Brilliant. And then another one back to you, Becca, here about follow-up about whether those fragments were ATP competitive or not.
Yeah, we ran one experiment and it was inconclusive. I unfortunately then left lab to go write my thesis and haven't been able to run any more. I should probably coordinate with people back in lab about running it again, unless Laura's had any success yet with crystals of where they're binding. No, then we'll try and find an assay to confirm where they're inhibiting.
Brilliant, lovely, thank you very much. Laura, update on fragment soaking crystallization.
So I'm trying to get new crystals to see if we can get a different packing for MURD, and I'm growing MURD crystals. They're not enough for doing the whole screen, but I'm working on it. We do have crystals for E. coli MURD and E. coli MURE.
Lovely, brilliant, thank you very much. Kato again, structure with the newly synthesized compounds. Anything to report? Ooh.
Yes, structures of the newly synthesized. So the fragments we did soaking at Oxford under supervision of Lizbe. And this is kind of an overview of what we did, but I think the data is not yet back. So I think once we have the data, we can report better on it. But
okay.
We were, yeah.
The data was collected on the weekend past. It's just I haven't looked at it, and I don't think Laura's looked at it either yet.
Okay, and I'm not super experienced to do that, so I'll leave it to them.
Cool, very good. Thank you very much.
Okay.
Lovely. Chris Dowson and Adrian Lloyd to give an update on enzyme assays. I don't see Adrian in yet. You're not at work, are you, Becca? Laura, are you in work? You're not in work either, are you?
No, I'm
the only one in. I need to probably run and give Adrian a poke just to see whether he's got the right link.
I can ask Julie.
Ask Julie, go and give him a poke. Okay, we'll come back to that. But the nub of it is we've made really good progress on the assays now for CD and E. Very happy with those, and we've crunched through some compounds. Should we go back then on? We'll come back to section 1 once Adrian's back. Section 2 then, atom-wise hits. Laura again, SPR. If you having to multitask. Let's come back to section 2. We'll move on to section 3 then with variants of AZ compounds. Yuhang here? Yes. Hi, Yuhang.
Hi.
We're going to skip forward to section 3.
Yes.
I can get my team organized. update on your AZ synthesis and derivatives. Anything new to report?
Yes, so as you guys can see on the GitHub page, I think the second last image, there are three about the current updates. The first session, AZ5595, with OSNA number 001051, is the I kind of improved. I modified the conditions and improved the yield from a literature reported 12% to 68%. So it's a major improvements on this. And about the second one, after I did all the equivalent screen, I used the best conditions to apply on the 21st one reaction. So with the bulk protected amine, bulk protected diamine, trying to do the SNR coupling, coupling to the core to make the bulk protected amine derivative of AZ5595. And the next step will be hydrolysis deprotection. It should be quick, but the whole process was a bit messy during this reaction because 90 minutes was clearly a bit of too much. So there are peaks. There's a one peak with the rights. So there are multiple products being generated. So I'm still working on that about the second section. So and about the third section, the synthetic routes for Young's predictions. As we have already discussed under it, we've only managed to secure three major predicted structures with synthetic routes because a lot of because some part of the structures were not purchasable for other predictions. So yeah, that's probably why we only select three of them to synthesize. They're all starting from very cheap starting materials. That's all. Sorry because I'm on the train, so sorry about the noise.
That's great. Thank you very much. That's great. Chemistry, a bit like crystallography, not always easily predictable, but well done. It's good progress. I think Adrian says he's might have to rejoin. There's no video. We do need the video, so we'll keep going. Adrian, if you can hear me, you can always run around to my office and or email me the presentation. And,
okay, can you hear me?
Yes.
Okay, I'll mail you the presentation anyway, and I'll come round to you.
All right, very good. See you in a while. Okay, so and then next one, Becca again. You've got a heavy session today, Becca. Did you get to look at Yuhang's compounds in August? We still got to do those.
They're still on our list to do. They were next after the enemy, I believe, on our list of the order of ones we've received and how we were working through them.
Okay, fine. So, yeah. And then, Yuhang, back to you again. We probably need to organize our agenda a little better so that yeah, don't keep flip-flopping. Or the chair ought to organize things a little better. Yuhang, do you want to say any more about the AZ compounds at all?
Right. So about the AZ compounds, I think previously was so the compound was with a OSA code 001044, and it's also on the on the agenda. It's also on the agenda called compound W. So that compound was sent to previously was processed by Peter, and now I think Yang's taking care of it about the crystallography data, and yeah, I guess we only I guess we need the final data from Yang maybe about to overlay it with AZ5595 in PDB 6X9N and AZ A074 in PDB 6X9F. I think, yeah. So that's the part we need from Yang in the US, I think.
Okay.
Yeah. And about the second one, to ship AZ5595 to SSGCID, yeah, I've already got the very pure compounds, and it's a time thing. Matt wants me to send other chemicals at the same time to save some shipments fees. So yeah, we'll probably delay that.
Sure. Okay, that's great. Okay, fine. No sign of Adrian yet. We'll come back to compounds, those AZW compounds, another time. I'm going to need some more input from Adrian on that right now, and we can't do that. Should we move on to new protein structures then? Joe, do you want to have any input around any reanalysis at all of the Pseudomonas myodine complex with ADP?
I'm not sure what your, I mean, whatever analysis has been done, it's all on the GitHub. I don't think I have any news.
Okay, there's nothing else.
Nothing new to add to that.
Okay, so where it says this question remains live is not really live still.
Well, I mean, for other people to input, but I've done my part.
Okay,
as far as I'm concerned.
Super. Okay.
I mean, we did. I mean, I guess I can't remember if that was in that section. I mean, we talked about more like truncated versions. I think the other, maybe that's a later discussion item or whatever. Maybe I can't remember where that falls in the long list about truncated versions.
Okay. Okay. Cool. Okay. Okay, I've got Adrian's PowerPoint, but no Adrian yet, so I'll wait for him to turn up. Do we want to then have a chat about the de novo computational modeling at all? Does Jan or anyone want to chip into that?
Well, I can just add that we're working on it. So we hope to submit some molecules for that. But that's ongoing, so nothing really.
Yeah, sure. Okay, cool. I'll zip down to 6 then, other potential start points. So Laurie suggested applying to the Merck Open Global Health Library. I think this is in lieu of us not really having any success with the European Lead Factory. I've had a look at that. I'm actually halfway through drafting an initial exploratory email to them on behalf of the whole group. But they are prepared to give access to compounds free, IP free. So we'll open a conversation and see what comes from that. But as with that and with the other compounds, I think we're quite quickly getting to the point that to maintain the bandwidth, we're going to need some more funding for people to be able to keep things turning over. So that'll be a key component. Right, I'm going to. No, Adrian's disappeared, so I can't show them and him talk to them. Laura, do you want to chase Julie again to go and chase Adrian? Thanks. before we get into the assay presentation, which will appear, does anyone have any more thoughts or discussions about anything they're involved with that's not captured by that quick run through so far?
So yeah, I guess I would just chime in again. I think we've talked about, the crystallography has been, at least in terms of getting with these fragments, has been a challenge. It's getting the right system in place for that. And so we did have this discussion. I brought up this idea of having a truncated version. I guess the other thing, so you guys now, I know in some of the other emails that you've actually made some UMA for the biochemical assays, and I'm just wondering if it's worth trying some of these crystal systems with UMA bound to see if that helps in basically stabilizing the system for with fragments. Yeah, so that's just, I guess that's one thing I would ask, maybe is possible to try if you actually now have UMA in the lab that could be used for some crystal trials. That would be, at least in theory, I guess, easier than doing all the microbiology and creating truncated forms and so on.
Yeah. Laura, have you had a go at that, adding any UMA to any of your crystals yet or not?
So I have added, but nothing has grown so far.
Okay. Okay.
But I'm trying different conditions. I did set up some crystallization plates last week. So I hope something will grow in the next couple of weeks.
And which Mur Ligases did you put those into? CDE?
E. coli, MUD.
Do you want to, what others are you going to be crystallizing shortly?
Say again, sorry?
What others are you going to be, is there anything else you're going to be setting up a crystal tray shortly? I'm just wondering whether we post some to Seattle.
Now that we have the new Pseudomonas constructs, I was gonna try that. I also have more constructs from Seattle, so I'm working on them as well.
Okay.
Yeah, I just need to get decent crystals.
Yeah. Yeah, very good.
So how close, so, obviously 2 UAG and 3 UAG are the E. coli MURDs that are in the protein data bank with ADP, but they have both UMA and ADP. And so I guess that was partly my rationalization for, at least trying the UMA. And I don't know what else they actually had. I mean, I assume those normally in the PDB, they have all the crystallization conditions are available within the PDB. So I don't know, I guess if you're kind of replicating that. Yeah, excellent. Thank you, Laura.
Yeah,
I really appreciate that.
I'm trying everything they wrote as well in the paper.
That's awesome. Thank you so much.
Problem.
Do you know if UMA is commercially available? So if so, we could just try it with the constructs we have here.
I got it from our own stocks in the lab.
Okay.
It wasn't commercially available 2 years ago or something when I checked.
Okay. Okay.
But I could check if we have enough to send you.
Yeah.
I check that. Right.
That would be great. That would be great.
Yeah.
No. I think we're about the only people who you can easily get hold of it from. So we've just made up another batch. We had some problematic with one of the reagents, but I think we've just about sorted that out now. Yeah, so we can do that. So should we? Yeah, Laura, do you want to arrange with sending some material over to Seattle then?
Yeah, I will.
Yeah, great. Yeah, we've got loads.
No problem.
Very good. I've got Adrian, and I think I've got a slideshow ready to show, but maybe not. Yeah. Okay. So if it's okay with people, then I'll share the screen. We'll go back to the enzymology section. think you're on, Adrian.
All right.
And I think it's left and right, but we'll see. Yes, it is. Perfect.
Okay. Right. Good afternoon, everyone. Sorry about the issue about my video camera. So we're just going to give you an update with regard to some of the entomology that we've been doing here with Mur D and Mur E. And I'll start with actually some of Becca's data. So this is her screening data with Streptococcus allegalactii Mur D. And these are the results of screening the enamine library that we received. And the screening was done with a derivative of ATP, deoxy-ATP, the rationale being that it had a higher KM, and therefore fragments will be better able to compete with the ATP binding site. So in actual fact, because the deoxy-ATP KM is high, it's about 1 millimolar, Becca was doing the screening at about 1/3 of the KM concentration. So we investigated these hits with the Pseudomonas aeruginosa Mur D and E, and we did it not with the same assay that Becca used, but with a fluorescent derivative of it, which is roughly about 10 times as sensitive. And this potentially would mean that we could use the native substrate because we can use far lower concentrations of nucleotide. And so before we did that, we just made sure that of the concentrations we needed to use, and we did that by determining the kinetic constants of Mur D and Mur E with respect to ATP. And with respect to Mur D on the left-hand side, the KM is of the order of 70 micromolar, and with Mur E, it's approaching 60 micromolar. So what we elected to do was to drop the ATP concentration in the screening assays to 20 micromolar, again 1/3 of KM. So we'd be working at an equivalent sensitivity to that Becca was using with the allegalactii enzyme. So we screened all the active compounds that Becca found against Pseudomonas aeruginosa Mur D and Mur E. So the two histograms represent the results of the screening. Compounds came from two plates, A01 and A02. The sea green color is the results from compounds in plate A01, the purple from those in plate O2. The DMSO vehicle is on the left-hand side with the brown bar at 100%, and the positive control, which is millimolar ADP-CP, which is an ATP analog, is on the far right in scarlet. And essentially we found 3 compounds in the Mur D screen that fell to around about 70% inhibition, that is to say 30% remaining activity. And with Mur E, 2 of those compounds fell into that category. And I've put the structures of FO9, N15, and MO2 below the corresponding data sets. Interestingly, compound LO6 appeared to inhibit both enzymes. That's the structure at the bottom of the screen. We counter-screened the compounds against the coupling system, and we didn't pick up any inhibition of the coupling system. And so that suggests that what we're looking at is the impact of the compound on the target. So moving on from this, because it's a different assay, it's a fluorescent assay compared to Becker's spectrophotometric assay, there are compounds in the one technique that do not actually have properties compatible with the second one. And one of these compounds is JO6. And JO6, we reassayed using the spectrophotometric assay that Becker had generated, but with ATP. And it turns out that it is a good inhibitor of Pseudomonas aeruginosa Mur E at 1 millimolar, and we have to characterize that further. With regard to LO6, the doubly targeting molecule, it has an IC50 of around about 355 micromolar. Now, if we compare that with a genuinely ATP targeting molecule, ADP-CP, the ATP analog, from the kinetic constants and the IC50, we can calculate it's got a Ki of around about just under 20 micromolar, which basically means that it's binding some 14-fold more strongly than the fragment L06. So we have a number of things we have to confirm. We have the other IC50s of the other compounds to do. We need to do a bit more mode of action work to prove whether or not LO6, for example, actually does target the ATP binding site. So there'll be a lot of competition assays to do. And that's where we are at the moment. We're also gearing up to start stopped assays on the remainder of the enamine library, and that is to follow. And that is where we are.
Lovely. Thank you, Adrian. Anyone have any comments? So from our perspective, we're now to the stage where we're pretty happy with continuous flow assays for any Mur Ligase, CDE, for any organism.
Yeah, we're validated, I think, for Mercy as well in a stopped assay. And those are the next validations we have to do for D&E.
So almost a complete set just around the corner. So certainly happy to receive more incoming material. I think we do need to get a kind of some uniform terminology around the projects and the chemical series. So if anyone's got any inspiration as to how we can order this, so there's any good chemoinformatics skills amongst us, then certainly appreciate some input as to how we set this up, so that we're all talking about the same thing and can quite easily flick backwards and forwards to capture all of the information that we have around assay information, structural biology information, etc. If anyone wants to help with that, please say.
I can propose something because I already started to do like a chart with all the work that we have been doing. So I already started naming things for myself. So I can propose those names. I can prepare that probably tomorrow because I'm in a course today.
Okay. Well, I think we probably need a kind of joint agreement across everyone what we want to call things. So
but I can propose what me and my colleague and see what people think. It might start the discussion.
Chris, you must have lots of experience in this area.
Yeah, I mean, it depends whether you want to something more systematic or you want sort of colloquial type descriptions of different series.
I think. What do you think? Do you think systematic is? Is it a point where, unless you're really into the chemistry, you won't remember where they all sit? Perhaps we need both.
It tends to be cumbersome. I guess that's the thing.
I guess I would encourage that we just basically name compounds starting with an identifier that is identifies the source. So whether it's diamond or enamine or UCLO or something like that, I think just having some generic, I don't know, whatever starting point and then some number, I would rather see, because I think one of the issues we have going forward is going to be, how things get resourced and where they go into grants and so on. So my personal bias would be that we would just identify using some initial set of characters that has where the source of the compounds, and then some number if you want to assign some number to them. But just using a single identifier for everything and losing the source, I think that, I mean, I know in the sense this is all one big happy community, but ultimately there will be, I think things will get resourced differently, in terms of either grant applications or where future work gets done. So I would encourage maybe just keeping the some kind of identifier that tells you where the original compounds came from.
The thing is, though, that if these are all acting at the same site, there's likely to be, well, there certainly would be one attractive thing would be to try and do mix and match and combine structures.
Yeah, exactly. Yeah. So I think there'll definitely be some hybrids going on.
Yeah.
Yeah, I think
at the moment, I don't think we have any evidence that any of these compounds, these are all actually acting at different sites. At least that's the UCL compounds and the Adam Weiss compounds are not at the same site. We've had that discussion, and they're not at the ATP site, which in theory what the enamine compounds were. So at the moment, I think these are all actually binding at different sites. So I'm not sure how much hybridization there would be within those kind of three different sets of compounds.
Yeah.
But once we know where they bind,
Yes.
Once we know where they bind, then I can see it happening, and maybe we have to characterize them ultimately by where they are binding. Maybe that's one way of helping. And I agree with you, Joe, trying to keep hold of the heritage and I guess we're still kind of stumbling our way through what open source, collaborative research looks like in the way of attribution to contribution, to the project as well. So we need to be mindful about how we capture all of that and retain all of that. So I know we do stuff, and I don't think I've posted anything on the GitHub page. So I think it'd be as though I don't exist. So we need to work out how we do all this. I think perhaps we have an offline discussion with those who want to be interested. I'll certainly include Matt, but Chris and Joe, anyone else about compound numbering and things.
Yeah. I think Joe makes a very good point about keeping a track of where the compounds come from. If nothing else, it helps when you come to write up papers and things like this.
Yeah, how were they derived? What was the computation?
Absolutely, yeah.
Etc. Yeah. Okay. Bart, do you have any updates from Seattle at all around future structural work that you might be doing that we're not aware of, or that you might be open for business to?
Well, I don't have any news on the recompetition of the Structural Genomics Center, but there will be a Structural Genomics Center. So whoever gets that contract, you guys, should work with.
When does that? When does the envelope get opened?
Probably in probably May.
Okay.
Certainly by June, I would expect.
Right. Okay.
And then in this project, we haven't. I mean, obviously, Jan has been doing stuff. Jan, that Jan's company will be moving. Will not be. They've decided not to be part of the recompetition. So at some point in September 1st-ish, Jan won't be able to join us unless he wants to on his free time.
That's really helpful to know. That was off my radar that was happening. So Jan, how much bandwidth do you have to help before you have forced retirement?
Well, it's an early retirement. Well, I was about to, our contract still lasts until the end of August. We will run out of hours that we are paid for probably in the time frame of July. There might be some exceptions for some projects that are ongoing. So at the moment, I can still work on things, and Laura and I just had a discussion on the side that she will send compound here. So that's not in danger at all.
Okay, great.
But going way into summer, I wouldn't think there will be a lot of work that will be done here.
Okay.
An on and off experiment, I wouldn't be worried about. But really anything systematic by summer, that seems unrealistic.
Right. And then practically, when do you think then, once the new contract is taken up, when do you think that is likely to get started again? And do we have to rebid to be accepted as a partner program, or are we a legacy that gets carried over?
Well, I mean, assuming that, say, the Seattle Structural Genomics Center gets funded, then all of our approved projects just continue forward. There's no you don't have to resubmit or anything. The group, the crystallography group that's taking over another work, they're going to have to hire a couple of people, and they're obviously not able to hire until they know that there will be funds, and so will certainly be a lag. There is a lag now because we're not replacing people that have taken other jobs and stuff until September. So we'll currently find that we're sort of in a little bit of a lag phase.
Yes.
On the chance that the Seattle group, we fail in our bid and they choose someone else, then the rules, I know that NIAID, the program officers will want to see this continue, and then they will most likely be moving, you'd be moving with a different place, but obviously I can't speak for whoever takes over and whatever their new process is.
Just at the mention of NIAID, we're just thinking about future funding opportunities. I mean, I'm looking around the UK and I'm scratching my head a little bit. I mean, I'm just wondering whether they would be open to a conversation about helping to materially fund some of the chemistry and biochemistry.
Right, and so I've had actually several conversations with NIAID people, including, I think one I invited Matt to sort of present a little bit about some of the projects. And, they're all very positive, but, they fund things with grant mechanisms. Like they don't get to choose, they don't have a pot of money that they can give to their favorite projects. They're like, oh, that sounds great. You should submit a grant. Right. And so that's what they do. And of course we know that, grants have about a 10% chance of getting funded. So not that we shouldn't submit grants, we should, there's no sort of like connection there. I don't even think it's D&DI really doing antibiotics. I forget if they had a program that they had an antibiotic resistance program.
Yeah. So I think, so Chris, there are two things. I think one, given kind of where the project is with any of the chemical series without MICs. So I think the most logical approach with NIH is something called an R21. So an R21 is basically a proof of concept grant. It's a 2-year grant. It's up to, I think, 275,000. So it's not a lot of money, but the idea in my mind, I think with Lori, would be to submit an R21 to support chemistry at Northeastern. And my bias, just be upfront, would be to follow up with the enamine compounds that we've worked on for 3 years now. So that, and then the second option, actually, the NIH has put together, or NIAID has put together a program to actually have library synthesis done on compounds. So you can make proposals, and they have a pot of money for synthesis of compounds targeting antibacterial resistance, AMR. So that's the other option. And I have a contact, former AstraZeneca colleague, Ann Aiken at NIAID. And so that's something we can talk about going forward about. But I think in the US, we're not in a position at this point, as far as I'm concerned, my viewpoint, to do an R01, which is the 5-year program, because we don't have strong enough data, preliminary data. So the idea would be to get an R21, generate that preliminary data that would support an R01, a larger grant.
So maybe a combination of the R21 and the NIAID compound synthesis.
Yeah, I mean, that would be, I think, from the US side, I mean, that's how I would see the potential opportunities for funding.
Yeah.
But again, it's small, the R21 is very small. It's $275,000 doesn't go very far when you start talking about the cost of a staff, a chemist, and overhead, and so on. Overheads can be quite painful.
Yeah.
Joe, have you ever talked to the Carbex people?
Yes and no. One of my very close colleagues from AstraZeneca, who we were also in Cape Town together, is a reviewer for Carbex. They're really, the issue with Carbex, although they've opened it up a little bit, is they tend to want to have, some equity. So we would have to have, before they would fund, they would look to have, you would have to have some additional, they don't do 100%, put it that way. So you need to have, some other donor support, financial support. I think that's still the case. And actually Carbex right now is waiting to be refunded by the NIH or NIAID. I mean, there was a proposal put out by NIAID, which basically was written with Carbex in mind. It's like Carbex being the only one who could meet all the RFPs. But they will get refunded, I'm sure, but that's still up in the air. But yeah, I think Carbex is we're not really in a good position for Carbex at this point. Would be my bet, but others may feel differently, and it doesn't hurt to reach out. But we just don't have at this point. We're basically got fragments and no antibacterial activity, and that's not a great. That's not too enticing right now for a funder. You'll have to get farther along the development of the compounds.
Yeah, so NIAID has consistently funded antibiotic resistance drug development projects. They have an RFA, it's almost every year, I think, and I saw one, I think, come out a couple of weeks ago. They're very product development oriented. You have to have a product development plan, which basically means you need a preclinical candidate, or at least are capable of getting to a preclinical candidate within a short period of time, which is, and that's true kind of whether you talk to drugs DNDi or Carbex. Everybody wants a declared preclinical candidate before they sort of are willing to talk to you or give you any money, which of course we know is kind of a tall bar to get to, right? I don't know how you're supposed to get there, but it's been my experience anyways.
Yeah. Good. Got a few more minutes left. Does anyone have anything else they'd like to say, particularly anyone who's not contributed would like to? No? Good. Okay, so we'll have a little working group on compound naming, and I think we do need a working group on funding. Scraping the bottom of the barrel from local funding just to keep things going, and then finding how we can push things forward enough to go for the medium and big ones, which we ought to do. I mean, we're getting some progress. We're getting some, multi-ligase inhibitors, which is great. And that was, the first set of compounds screened, 2 sets of compounds screened, and we've got 2 sets of dual targeting compounds. So it's got to be good. It's always up before it goes down. So enjoy the up. The reality of drug discovery. Very good. All right. Okay. I'm glad we got there in the end with the talk. Well done, Adrian. I just have to say, the team here, Adrian, Anita, and Julie, have been working 24/7 over the last couple of weeks just to get that data out. It looks like a few slides, but there's an awful lot of data points in there. So thank you all.
Welcome.
Good. Okay. Nothing else. I will pass off my bad impersonation of Matt Todd today, and hopefully he'll be with you again next time to have an improved service. Yeah, good. All right, everybody. Nice to see you all.
Take care. Thanks, Bart.
Bye.
Thanks, Jan.
Thanks,
Bye.
everyone.
Bye, everyone.
Thanks, everyone.
Bye.